All right, part three. So percentiles, as we saw just at the end of the last one, it's about all there is to it. You are given some percentile, you know that number as a percent is, or I should say, that number as a percent represents the amount of scores that are at or below the given level, So that's all you got to remember with it. So the 5-number summary in IQR, getting into this stuff here, first requires some knowledge of quartiles. So then we'll form a box plot with the 5-number summary. And box plots, I see these get used in a lot of like manufacturing areas. That's where I've seen them show up in real life applications, because they can quickly show you the spread of things rolling off the assembly line. They can show you where, half the data is. And if, there's a lot of outliers out there, you'd see these things really quickly in the picture. So they're really helpful for that sort of scenario. And they are commonly used to understand how the data in a data set is distributed. So they're similar to percentiles, except that instead of 100 parts, like percent means per 100, like literally means per 100. So, that's why there's 100 cents in a dollar, 100 years in a century. So percentiles have 100 parts. With a quartile, a quarter, there's 4 quarters in a dollar. So there's only going to be 4 parts. And note that you only need 3 dividers to split a data set into 4 parts. If you have a cake like this, and you cut it in half, and then cut each half into half, and I must not be good with my cake here because somebody's getting a smaller piece, but at any rate, the idea here is that you now have 25% of the data roughly here. Might shift around a little for smaller data sets, but larger data sets, you're really close to having 25% of the data in each of those 4 regions. And the median would be right in the middle. And then you have what's called the first quartile, Q1 here, and the third quartile up here. The second quartile is actually the median. So for the first quartile, the 25th percentile, 25% of the data falls at or below the value. The second quartile, the 50th percentile, also known as the median, 50% of the data falls at or below this value. And then the 75th percentile is for the third quartile, and 75% of the data falls at or below this value. And in fact, if you look up here again, from here down this way, 25 plus 25 plus 25 is 75%. So quartiles themselves are 3 of the 5 numbers in the 5-number summary. So if you're finding quartiles by hand, you'll need an ordered data set, because the median is used. Already kind of referred to that a little bit, but the median gets used. Then what you're going to do is find the median, i.e. the second quartile. So you find that first when you get your ordered data set. Next, you're going to find the median of the first half, i.e. the first quartile, and the median of the second half. So it's all medians. Median to split it in half, the median to split each half into half and give you 4 quarters. And that median of the second half is called the third quartile. So for example, if I gave you this data set in order, I'll be nice. 1, 2, 7, 8, 11, 13, and 17. The median is 8. So this is going to be the second quartile. And then I've seen different ways of approaching this in different books. This book and Desmos do it in the way that is most commonly used. But once you have an ordered data set, and if you just find a median as a number, it's kind of like a toy that got taken away from siblings because they couldn't agree on who got to play with it. the two halves here couldn't decide who gets the 8. It's like, do you get it? Do you get it? No. And some people are like, well, you both get it. But I remember when I was a kid, if there was one toy and we were fighting over it, nobody got it. The toy just went away until we figured out that we had to share. So that's how it is here. There's only one 8. Neither half gets it. And now you look at each of the sets that's remaining, and you find the median of what's left. So here, the 2 would be the first quartile, and then the 13 would be the third quartile. You can also use technology to find the quartiles. So let me go over here to this. And again, the stats is already up here. I'm going to get a new little box here. And if you look at, we have quartile and quantile. We aren't going to do quantiles in this class. We're just going to do quartiles. So be careful there. And right here, this is kind of nice because like, oh, how do you type this thing in? It gives you this little exclamation mark. And if you hover over it, it'll tell you. It requires 2 arguments. For example, try typing quartile 1, 2, 3 in square brackets and then 1. And what that is you're getting the data set and then you're telling it to give you the first quartile. So let's go ahead and do this with that data set we had just to verify. So we have the 1, 2, 7, 8, 11, 13, 17. And I think you can put these out of order and it'll even do it for you. And then 1, and notice it tells you the first quartile is 2, just like what we found. And then you're like, oh, what's the second quartile? I want to know that. Well, then you put 2 in, which is actually the median, and it gives you the 8. And you're like, oh, what's the third quartile? And you put in the 3, and it will give you the 13. So you just have to put the data set in square brackets, and then put a 1 to get the first, a 2 to get the second, and a 3 to get the third quartiles. Pretty easy. Okay, so going back over here then, let's see. So once you have the quartiles, you just need 2 more numbers for the 5-number summary. 5-number summary is going to be set up with the lowest data value known as the minimum, the first quartile, the median or second quartile, the third quartile, and then the highest data value known as the maximum. So what I want you to do is find the 5-number summary for this following data set. Make sure you pause. Okay, so hopefully you paused and came back. So looking at this, we have an even amount of data values here. It's like, oh, maybe you got stuck on that. Well, the median here is now, oops, that should be a capital M, sorry. The median is going to be 6.5. So that's going to be your second quartile. And now when you have an even amount of data values like that, the median technically falls in between here. So you don't kick the 6 and 7 both out. This is like a situation where you got 2 toys that are similar. They'll make both kids happy even though they're not exactly the same. So you can split it up like this. Be like, hey, look, you get to play with that toy, and then this side gets to play with that toy. And if you don't like it, then we'll take all the toys away. But anyway, yeah, there was a lot of toy issues in my house, I guess. But at any rate, when you have something where the median is in between, or you have an even amount of data values in the data set, you do give one of the ones used to find the median to one side and the other one to the other. And then looking here, we again have this 2 values in the middle for the first quartile. So the Q1 in this case, the average of 2 5s is just going to be 5. And then for the second half, we got these 2. So Q3 would be 9 plus 11 over 2, or 10. So then the 5-number summary is going to be 2 for the min. It's going to be 5 for Q1. It's going to be 6.5 for Q2, or the median. It's going to be 10 for Q3, third quartile, and then 13 for the max. And this is the final answer that you'd be looking for here. All right. So sometimes it is useful to know the spread of the middle 50% of the data, because that's where, in the middle 50%, you're getting away from the outliers that are on the ends. So it kind of gives you a nice idea of how, half the data set right there in the middle is spread out, and, a good idea of, typical values, how much do they differ from each other. So the middle 50% is located between the Q1 and Q3 quartiles. So visually, again here, just real quick, you got your median here, you got your first quartile, your second. So overall, you're looking at right here, this is the middle 50%. So this middle 50% spread is defined as follows. It is the IQR, the interquartile range. That's what that IQR stands for. And it's found just like you find other ranges, except you're not subtracting high minus low, you're subtracting Q3 minus Q1. So find the interquartile range of the data set in that example. Go ahead and pause. All right, welcome back. So the IQR in this case is equal to 10 minus 5. We found that Q3 was 10, Q1 was 5, so you get an IQR of 5. So the spread of the middle 50% is just 5. All right, box plots. These will use a box to clearly show the middle 50% of the data set, and line segments to represent the lower and upper 25% of the data set. So how do you create one? Well, let's revisit the results of example 4. And let's see here. I'm going to go ahead and pause this because I do want to just have 3 parts of this video. So I'm going to go ahead and draw it and I'll talk about it. Okay, so this is what a box and whisker looks like. Some of the key elements here, there's always a scale. And the scale in this case is this thing right here. It's a number line. That's all you got to think of it. And on that number line, you don't have to put all the tick marks in. If you aren't good at relative spacing, by that I mean between the 2 and the 5 should have less or more distance, I should say, than between the 5 and the 6.5. If you aren't good at relative spacing, you may want to put more tick marks in to make sure that, the numbers aren't all clumped together, because you really want to show the spread of the data visually. And it's important to see that in this box, the right part of the box is spread out more so that third 25% of values are spread out more than that second quarter of values. It's important to show that visually. So make sure you do have the tick marks spaced relatively, correct. And then you have a little box up here. And notice that the box starts at Q1 and goes up to Q3, and then you show the median in the box as a line. So you got your Q1 to Q3, and then the median. And then you will also have whiskers, as they call it sometimes. Box and whisker plots is another name of these. And the whiskers are just little line segments that go out to the max and min on the left and right. You'll see variations of these when outliers are present sometimes, but they don't do a lot with that in this book or this class. But that's the basic idea of a box plot. So what I want you to do is create one for that 5-number summary. Go ahead and pause. All right, you should be seeing something like this. Most common mistake I see with students that are doing these is they have the box and whisker part touching the number line. Your box and whisker should never touch the number line. The number line is just a scale to tell you how the numbers relate to the box and whisker, but you should never see this thing like drawn actually off of it down here. These things should not be connected. The number line should be floating with space away from the box and whisker, always. Okay, so if you have questions about this, make sure to ask, and hopefully this gives you what you need to succeed in the homework.